Welcome everyone to this video where you are going to learn about identity operators in Python. Before going into details for identity operators in Python, I will just like to refresh some of the ideas about variables and the memory locations assigned to those variables and how the identity operators can be useful. So let's take an example. For example, if we have a variable x and we assign a value 10 to this variable x. Now we know that whenever a variable is initialized, it is assigned a memory location in computer. So this variable, for example, is assigned a memory location B65E. I just gave it a random memory address for this variable x. Now this x is pointing to this memory location. Now we actually write a code where we say y is equal to x. What we are doing, we are assigning x to y. In this assignment, what will happen is that this y will also point to this same memory location. And that is what we can check if two objects, two variables are pointing to the same memory location using the identity operators. One also additional thing that I would like you to know about is that even if you have the same value, for example, if we have a variable z here, which also has value 10. Now what will happen for this variable, even though it has the same value as x that is stored, it is a new variable. It will be having a new memory location, and this will be assigned to another memory location which can be 0xCF4E, for example. Now they are actually pointing to two different memory locations. X is pointing to this memory location, Z is pointing to this memory location. So if we check with the identity operator, X and Z, they point to two different memory locations, whereas Y and x, they both point to the same memory location. That is what we can check with the identity operators. Let's take the example from the code. Here we have x and y, and if this is not familiar to you so far watching my videos, then I just want to actually add this information here that I will launch some new videos where I will be explaining list, dictionary and other data structures, but there is a reason I included list here, and just to give you an information that there cannot be just one value as I demonstrated. It can be several other objects in Python like lists, and list is actually a collection of elements enclosed in square brackets and separated by a comma. So here you can see we have a square bracket, we have 1, 2, 3, and square bracket is closed. This is called a list representation of data with 3 elements in it, 1, 2, and 3. And this information will be useful when we go into the next video, where we will also discuss about some other operators as well. And as you can see, when I initialize variable x with the list here, it is pointing to a memory location A, for example. Then I have y, which has the same list, but now it will be pointing to a different memory location, even though the values are same. If I say x is assigned to z, z is equal to x, and if I print x is y, so remember is the identity operator. So whenever you write is, it means identity operator. X and y in this example, they are not pointing to the same memory location. X is pointing to the memory location A, y is pointing to the memory location B. So what will happen? That identity operator should return false, because here x and y, they both have different memory location. But when I say x is z, x and z are actually pointing to the same memory location, so they will have the result true. And if I say x is not, remember is an identity operator, and is not is also a combination of Boolean logical operator and also the identity operator. So it just wants to check if X is not Y. So it should be true, because X and Y are not pointing to the same memory location. I will run this cell with Control Enter, and it is in front of you. X is Y is false, because X and Y, they don't point to the same memory location. X is Z is true, because X and Z, they both point to the same location. X is not Y. What does it mean? That X and Y, they don't point to the same location. That's what we are writing here, which is true, because X and Y, they don't point to the same memory location, so the result will be true. If I say X is Y, it is false, because X and Y, they do not point to the same location. But when I say X is not, then this statement becomes true. And also this identity operator is used to check if the flag is true as well. So for example, commonly we have these Boolean values and we want to check if they are true or false. We can simply say, if the Boolean flag has a value true saved in it, I can print Boolean flag is false. But right now it is true. So when I say it is false, they will not be pointing to the same value, same data structure. So this will become actually false when I execute this cell. See? But if I write here true, like this, so Boolean flag has value true, and Boolean flag is true is a identity check for Boolean flag if the Boolean flag is true, and this time it will be true. Then one very interesting thing about none values. What is none? None is nothing, yes, but we will even see it in more details in next few examples, but I want to explain none here as well. For example, if you have A equal none in Python, it does not represent any value. So it indicates that there is no value for A here. And there are some conditions or some scenarios where we were expecting a value, but we do not receive a value for a variable, and then it's assigned a value none, a none representation. And a common way to check if a value is none or is not none is this identity operator. And over here we have this example where we say X equal none. So X is assigned a value none, and as in a none representation. And if we say X is not none, then it will become false, because X is actually none. X does not hold any value, just none. Or we can say, when I say X is none, it will become true. So in our next video, we will learn about membership operators. Till then, keep practicing all these things, and I'll see you in the next video. Till then, have a good day.